Elements and ions, Chemistry 150. Elements. Each element has a name and a chemical symbol that is either one or two letters. The periodic table lists all the known elements. The first letter of each symbol is uppercase, and if there's a second letter, it's going to be lowercase. The columns have names, such as main group A and transition elements B. Which elements do you need to know? Let's go through the list. The periodic table that we will be using is the one that you see here, and please note group A is columns 1 and 2, going on through columns 13 through 18, or groups 1A through 8A. The transition group, or B group, are these columns here, and these columns down here at the bottom, which are part of the transition. Going across the rows, but up and down, are columns. The alkali metals are group 1A. Make sure that you know how to spell the name correctly and the chemical symbol of the following: lithium, sodium, potassium, rubidium, cesium, and francium. Group 1A metals are extremely reactive, and when they undergo chemical reactions, they tend to form 1 positive cations. The alkali earth metals are group 2A. Beryllium, magnesium, calcium, strontium, barium, and radium. These are also reactive, but oftentimes not as reactive as group 1A. And these elements tend to form 2 positive cations when they undergo chemical reactions. Transition metals, or these are metals from group B. Manganese, nickel, zinc, silver, gold, mercury, copper, iron, chromium, vanadium, palladium, platinum, cobalt, cadmium, titanium, and tungsten. This is a selection of the transition metals that you need to know. And these elements may vary in charge as ions. They tend to form cations when they undergo chemical reactions. We will be able to tell based on their one type of charge they form, or from their name or chemical symbol in the chemical formula. Other metals. Make sure that you know that from group A, aluminum, tin, lead, gallium, and indium are metals. Sometimes these are called post-transition because they come after the transition metals, but they're still main group metals. Group B, or inner transition, uranium, plutonium, neptunium, cerium, and californium. Metalloids, group A. Metalloids that you need to know are boron, silicon, germanium, arsenic, antimony, tellurium, polonium. Of the nonmetals, make sure that you know group A, carbon, nitrogen, oxygen, phosphorus, sulfur, selenium, and hydrogen. Even though hydrogen might be on the left-hand side of the periodic table, it is still a nonmetal, and nonmetals are all in group A. The halogens, these are nonmetals in group 7A. Fluorine, chlorine, bromine, iodine, astatine, and these elements tend to form 1- anions when they undergo chemical reactions. The noble gases, this is the very last column. These are also nonmetals and part of group 8A. Helium, neon, argon, krypton, xenon, and radon. The diatomic elements: hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, bromine. And one way to remember that these elements in nature exist as diatomics is to remember the refrain: have no fear of ice-cold beer. What you want to make sure that you do is whenever you read the word hydrogen, is that you write it as H2 in the gas state, unless you are told otherwise. What's otherwise? You are told it's the atom. Atoms are monoatomic, while the diatomics are molecules. The chemical formula format. Consider the chemical symbol X. If X is inside an invisible box, there are 4 corners, and all 4 corners gives us useful information. We're going to focus on The right-hand side superscript, which means on top, and subscript, which means on the bottom. On top, or superscript. If we see something there, that's the charge. If there is no number, that means there is no charge, and that means we're working with a neutral species. If we see a number subscript, we're going to see either 2 or more. That's letting us know on the right-hand side subscript that we have 2 or more of x. If we only have 1 of x, then we don't write the number 1, the symbol is more than enough. When there are 2 or more atoms present, such as in a compound or polyatomic ion, one can write a chemical formula. For example, H2O. By looking at this chemical formula, we should be able to tell that we have 2 hydrogens and 1 oxygen. There is no charge, it is overall charge neutral. The list of polyatomic ions. This is the list of polyatomic ions that you must memorize. You need to know what they are. Whenever you see a specific grouping of atoms with a charge, then we know it is a polyatomic ion, a many-atom charged species. For example, ammonium, NH4, has 1 nitrogen and 4 hydrogens, but it also has an overall positive charge, and that's how we know it's ammonium. Our goal is to ensure that we have memorized these by practice. So we're going to practice until we have these down, and once we've practiced enough, we should be able to go back and forth with ease. You got this. Let's go ahead and note where we find these polyatomic ions. Let's start with ammonium, NH4+. Cold packs may contain ammonium nitrate, for example. Acetate, C2H3O2- or CH3COO-. Asparagus contains methonyl acetate, which is believed to be that asparagus aftertaste. Hydronium, or H3O+. The citric acid in lemons reacts with water to produce hydronium ions. Cn- or cyanide. Almonds naturally contain tiny amounts of cyanide ion. OH- hydroxide. Sodium hydroxide is a major component of lye. Lye is used to make soap from fats or oils. O2 with a 2- charge is peroxide. Hydrogen peroxide is used as an antiseptic. MnO4- permanganate. Low concentrations of potassium permanganate may be used to remove pollutants from water. SCN-, thiocyanate. Copper 1 thiocyanate may be used in flame retardants for PVC plastics. S2O3 with a 2- charge is thiosulfate. Sodium thiosulfate may be used to treat cyanide poisoning. C2O4 2- oxalate. Kidney stones are composed primarily of calcium oxalate. NO2- nitrite. Processed meats like hot dogs contain preservatives such as sodium nitrite. NO3 with a minus charge, that's nitrate. While nitrate compounds are components of fertilizer, groundwater contaminated with nitrate compounds can cause adverse health effects. ClO-, hypochlorite. Bleach contains sodium hypochlorite and is used as a disinfectant. ClO2 with the minus charge is chlorite. Sodium chlorite may be used for textile bleaching. Once bleached, dyes may be added. ClO3- chlorate. A match head may contain potassium chlorate, among other substances. ClO4- perchlorate. Compounds with perchlorate have many uses, but it is known to contaminate groundwater and thyroid problems. BrO- hypobromite. Hypobromite containing compounds are often used as germicides. BrO2- bromite. Compounds with bromite may be in the paper industry to increase the wear strength. BrO3- bromate. Potassium bromate may be added to dough to improve baking uniformity. BrO4- perbromate. Perbromate itself is difficult to synthesize or make and is a strong oxidizing agent. IO- hypoiodite. Hypoiodite in the acid, HIO, has applications in rocket fuel. IO2- iodite. The iodite ion is unstable, but may be an intermediate or an in-between the iodide ion and the iodate ion. IO3- iodate. Potassium iodate may be used during nuclear emergencies to stop the thyroid gland from absorbing radioactive iodine. IO4- periodate. Compounds with periodate have been used in pyrotechnics as oxidizing agents. CO3- carbonate. Chalk is composed of calcium carbonate. HCl3- hydrogen carbonate or bicarbonate. Baking soda is a common name for sodium bicarbonate or sodium hydrogen carbonate. CrO4- chromate. Chromate compounds may prevent corrosion of some metals via chrome plating. CrO2O7- dichromate. Potassium dichromate is used in the tanning of leather. SO4- sulfate. Magnesium sulfate, also known as Epsom salt, is believed to have therapeutic benefits. HSO4- hydrogen sulfate or bisulfate. Sodium bisulfate may be used in dishwasher cleaners. SO3- sulfite. Sodium sulfite may be added to dried fruit to keep its appearance fresh and as a preservative. HSO3- hydrogen sulfite or bisulfite. Compounds containing bisulfite may be used in the production of dyes. PO4- phosphate. Energy to move or muscle contraction comes from ATP, adenosine triphosphate. ATP contains 3 phosphate ions. HPO4- hydrogen phosphate. A common use for hydrogen phosphate salts is in fertilizer. H2PO4- dihydrogen phosphate. Potassium dihydrogen phosphate may be used on fruits to prevent mildew growth. Make sure to memorize. The list of elements and ions take time to memorize. Practice until it is in your memory bank. It is our chemistry alphabet, and the more you practice, the more it will stay in your short-term memory and eventually in your long-term memory. The key is practice or rehearsal.